Hello everybody, we have a GRE physics problem here to solve. This problem is regarding mechanics. In this problem, a ball of mass m which is suspended on the end of a wire as shown in the figure is released from a height h and collides elastically when it is at its lowest point with a block of mass 2m at rest on a frictionless surface. It is asked what height will the ball rise to after the collision, and our answer should be one of these five options: A, B, C, D, and E. Our plan for the solution to this problem is this. We need to find out uh, the velocity of the ball immediately after the collision, and this will allow us to find out the kinetic energy after the collision, and this kinetic energy will then be spent in rising the ball up to some height, thereby converting the initial kinetic energy to potential energy. And this thus allows us to find out the height to which the ball can rise after the collision. So this is the plan to the solution of this problem. Usually in the physics textbooks, the elastic collision equations are derived for two balls, but these equations are equally valid, for example, for two blocks colliding on a frictionless surface, or a ball and a block colliding with each other on a frictionless surface. Now let us assume we have a ball of mass m1 which initially is moving with a velocity u1 to the right and which collides with a stationary block of mass m2, velocity u2 is equal to 0, and the velocity of the ball immediately after the collision is given by this expression. u1 prime is the velocity of the ball after collision. This is equal to m1 minus m2 divided by m1 plus m2 times u1. You can find this expression in your textbooks. It seems that you guys need to remember such formulas before you go to the GRE exam. Now in this formula for u1 prime, m1 and m2 are given as m and 2m, but u1 is unknown. And this u1 can be found readily from the energy consideration of the problem. Now initially the ball was at a height h, and at this point the energy of the ball was totally potential energy, which was mgh. Write down mgh, and this potential energy is converted totally into the kinetic energy at the bottom. So this potential energy should be equal to the kinetic energy at the bottom of m u1 squared. And from this expression you can find out u1. M and m cancel out here, and u1 is equal to 2 times gh under the square root. Now plug in this value of u1 and the value of the masses in expression for u1 prime. So you get here u1 prime is equal to m1 mass of the ball, which is m, minus m2, which is mass of the block 2m, divided by m plus 2m, this whole thing multiplied by u1. So u1 is 2gh under the square root. This is u1. Now the kinetic energy of the ball immediately after the collision is half m u1 prime squared. So kinetic energy of the ball after the collision is equal to half m u1 prime squared, and plug in the value of u1 prime here. So you get what? Half m u1 prime is this value. Now this can be simplified also here. This is equal to minus 1 by 3, because this is minus m divided by 3m, so minus 1 by 3, and m cancel out. So 1 by 3 times 2gh under the square root. This is the value of u1 prime. So plug in this value here. Minus 1 by 3 times 2gh under the square root whole square. And this gives you the result here. Kinetic energy of the ball after the collision is equal to this is 2, so this is 1 by 9. 1 by 3 square is 1 by 9, and 2 and 2 cancel out, so this is mgh. Now this is the kinetic energy of the ball immediately after the collision, and this kinetic energy will be used in rising up the ball to a height, say h1. So at that point, the energy, the potential energy of the ball is mgh1. Write down potential energy of the ball at height h1 is this, and this should be equal to the kinetic energy of the ball at the bottom. So 1 by 9 mgh, and you see this mg and mg cancel out, and h1 is equal to 1 by 9 h. So guys, answer A is the right answer. So this one is the right answer, and thank you for watching this video.